Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you here today, as it is every day here in my virtual classroom. Okay, step on inside here, and we are doing an entire new unit, and I actually skipped a video of sorts. I'm working with conic sections, but not all of them. If you know what conic sections are, well, if you do or don't, there is a basis here where we deal with circles, parabolas, ellipses, and hyperbolas. We are not going to, or at least my class is not dealing with the ellipses and hyperbolas, just circles and parabolas. And we already we already did our circles thing together. I may have some videos on circles from a previous class, so I have that. Now I do have old videos on conic sections as well in general, so I will leave a link down below if you want to get a bigger deal on conic sections with circles, parabolas, ellipses, and hyperbolas all together and what they are. I will warn you that where I use the letter C when we talk about something involving parabolas, now we're going to be using the letter P. They are interchangeable. It's just how a book works. It's how a class works. It's how me teaching it over 7 years later or whatever works, and some things change there. This video is going to be focused on parabolas. So the circles bit, I don't know, I'll do some review eventually later and talk about the circles bit, but they all have the same basis when it comes to some aspects such as completing the square, things like that. But this one on parabolas has a little more to do than just graphing out a vertex form, which we will do. The first 6 problems, I believe I'm actually graphing out a vertex form. We are going to have parabolas that also open left and right. We're also going to be talking about the focus and the directrix of parabolas, which is the part where it involves a P instead of a C, whatever. Now, this video has 28 problems on it, and you know, me kind of being a little out of whack right now, out of sorts where I'm at right now. I'm gonna not have to live on this as long as I'd like to. Obviously, this video is already recorded by the time that you watch it, so the timestamp is what it is. It would be amazing if I got this under an hour. I don't know if I will, but I'm gonna do what I can. I'll tell you what, when I'm doing the graphs, I've done these kinds of graphs before. Even if we hit the x equals y squared equation instead of y equals x squared, the HK and stretch factor stuff are all the same as they are. So these first 6 graphs are just, I'm going to be very to the point on them and get those started, kicked out of the way. Then we get to talk about completing the square, which I do have some videos on completing the square, but I'm going to explain it a little bit, and then I'm just going to go through. So hopefully these are things you've picked up on. You have to know something about graphing out a vertex form with parabolas, even if not sideways, even if it's the first time you've done sideways. Doing things involving completing the square, and that includes sometimes factoring out your A value, or if not all the time. And then I will talk about the focus and directrix a little bit there, but once we get it calculated, you got to know how to work fractions. And that's the big thing, actually working fractions, improper fractions, things like that. And I haven't done the worksheet, so to speak. I've assigned it to my students. I've created it. It's something where problems are kind of pre-generated in a way, but I haven't done it yet. So I'm going to go ahead and do it right now. Nice little long intro there. Let's go ahead and get started. You have 2 different forms that we're going to be looking at here with vertex form. There's y equals a times x minus h quantity squared plus k. Something where if you've been with me during this year or something on this channel before, this is not unfamiliar to you. This is all about quadratics here. Once you've located your hk, your vertex, such as this vertex is at 4, 0 right here, it's all about how this is quadratic behavior. Over 1 from the vertex either way is up 1 squared, over 2 is up 2 squared, over 3 is up 3 squared, with the exception of taking half of that height. So instead of 1, 1, it's 1, 1/2. Instead of 2, 4, it's 2, 2. This is the kind of stuff that I'm planning on doing quickly. Instead of 3, 9, it's 3, 4.5. That's half of 9. And half of 16, which is 4 squared, is 8. And reflected on the other side is this. So these are the parts, like I said, not going to spend a lot of time on. I'm going to graph it and get it out of the way, especially as you're maybe checking answers and maybe you know what you're hearing out of my mouth when I say those things. Hopefully there's an aspect of that'll definitely work. All right, y equals negative x plus 3 quantity squared plus 1. This vertex is at negative 3, 1, and this opens downward. This is an a value of negative 1 here. So I'm going to start at negative 3, 1 right there and open downward 1, 1, 2, 4, 3, 9. Reflect across the axis of symmetry 1, 1, 2, 4, 3, 9 like that. That's my parabola. You can see it's what I call 8-second graphs. I don't think they really take 8 seconds, but that's what I call them. I don't know why. 2/3. I don't do that kind very often. Now get used to having fractions out here for these things, and you're actually going to appreciate a fraction of a quarter or less, like an eighth and a 16th and stuff, if we ever run into them, because of what they do with the focus and directrix on these once we get to those. All right, now this vertex is at 3, 2 right here, so 3, 2. And this opens upward, but we got to take 2/3 of our values. Instead of 1, 1, it's 1, 2/3. What's 2/3 of 4? 2/3 times 4 is 8/3, which is 2 and 2/3. It's those kinds of things that maybe you don't really plot that point if you don't really know what it is, but there it is right there. 2/3 of 9, which 3 squared, is 6. So that's 6 up from 2, and that's right there. And that's really as much as we can fit. So 2/3, 2 and 2/3, 6. And hey, it's still a graph. It's still a graph. It still works out for us. No problem for me there. All right, now we're going to deal with some x equals y squareds. And, you know, this general form looks like x equals a times y minus k quantity squared plus h. Now, the vertex is still at hk, but you can see that the h is associated, well, separate with x as far as equation-wise, but it associates with x the same way that k associated with y. You can see the y associates with k the same way that x associated with h. So the vertex is still at hk there. The difference is, you know, you don't flip the h and you do flip the k now, and you got to see them in those different spots. And the a value no longer represents a vertical stretch factor, now that x is the one being affected by what a does after you plug in y. Now it's a horizontal stretch factor. And what I've just been telling my students, at least today, or, you know, whenever they see the video, in our class when I introduced it was you might just want to flip your paper over, you know, rotate it, and just treat it like it's facing upward wherever you go. That might make it easier for you. Now, the other thing is this is a sideways facing parabola. If a is a positive, it opens right. If a is a negative, it opens left. So let's see if we can make sense of this right here. This vertex is going to be at -4, -1. Notice this is my h and my k. You take the opposite. Plug in -1 into here, you get -4, which is a minimum for x. So -4, -1 right here. This graph opens right. The a value is +1. If you turn your head, I guess we have to do this for the screen, but if you turn your head or turn your paper or whatever, you can make it appear upward. So now you kind of have like a 1, 1, 2, 4, 3, 9 business going on like that. Just kind of work that way. 1, 1. It's almost like doing the square root graphs. The major differences are this is a full parabola instead of a half parabola. So this is not a function, by the way. It's a full parabola instead of a half parabola. And the a value, and then the h and k are flip-flopped. And then the a value, it's not a vertical stretch factor, it's a horizontal stretch factor. This one was 1, so you didn't get to observe the change. On this next one, you will. Okay, this next vertex right here is at 3, 1. So we're going to start right here. This is a negative horizontal stretch factor. It's a -3. It's going to open to the left. So that's where you kind of have like a 1, 3, 2, 12. I can't really go 12. 2, 12 like that. It's a 3 times 4. 1, 3, 2, 12 like that. And when I say 2 and such, I'm going up and down on y instead of on x. It's like if you rotated your paper. So it is horizontally stretched, as opposed to if this was a square root graph, this would still be vertically stretched and would just flip upside down. It wouldn't go, well, it goes left to right, but the reflection is based on y. This last one, x equals. Now this 1/4, something again, hopefully you'll be comfortable and familiar with these down the line. The vertex is at 2 for x, or for h, -2 for k. We start here. This is x equals 1/4 y squared. This will be positive opening to the right. Instead of 1, 1, it's 1, 1/4. Instead of 2, 4, it's 2, 1. Instead of 3, 9, it's 9/4, 2 1/4. It's 3, 2 1/4. Instead of 4, 16, it's 4, 4. So 3, 4. 5 is 6 1/4. That would be about right here. Can't really fit much more than that. So 1/4, 1, 2 1/4, 4, 6 1/4. I kind of like those ones. That's not actually the point. Okay, so those are the first 6 graphs. Like I said, I wanted to get those ones out of the way, and all my graphs here on out, if they're in vertex form, you'll kind of see me just kind of boom, boom, boom. I really want to get those ones done and taken care of. Okay, the next 4 problems, we are going to be writing vertex form of the parabola when it's either in standard form or general form right here. The end goal of this thing is we need to make it look like that y equals, or x. It looks like all these will be y equals, but a y equals a times x minus h quantity squared plus k. And my students should have been able to have done some of these in the past, in the year past or whatever. But when you're in general form right here, it might look a little different. And this is where kind of circles came into play. They had general conic form for circles as well, and they put it into their standard form. So there's that. I got to remind myself to provide that link of that older video. And it is older. I'm not on screen. It's kind of poor mic quality. I don't know if the problems are any good. But right here, here's the idea. We got to use what's called completing the square. Completing the square takes your x squared term and your x term, and it finds a constant that builds and makes this a perfect square trinomial, so we can factor it down to this. Now, in order for this to work, this needs to be a 1x squared, and right now it's a negative 1x squared. It needs to be a positive 1x squared. So you will force factor the quadratic coefficient out of this. I'm going to factor a negative 1 out of the first two terms, and I'll be left with x squared plus 2x. That plus 8 is not involved in completing the square. I'm going to leave it outside here. Now, what I'm going to do is I'm going to be adding, and I got to say this really briefly here. I can link you to another video on completing the square, but I got to say this stuff really briefly here. I'm going to add a value inside of here that'll make a perfect square trinomial. Given the 1x squared, you take your linear coefficient, divide it by 2 to get 1. And you square that value, divide it by 2, and square it. You square it and you get 1. Now, I just artificially created a plus 1 in the factored portion right here. Whatever I add to complete the square right here, I must also subtract if I'm on the same side of the equation right now. Because what I just did was I just made this 1 bigger. I technically made it 1 smaller. You have to distribute the negative 1. We're going to talk about that. But whatever I add, I also have to subtract. Okay. Now, the fly in the ointment here is this was not just a plus 1, right? If you distribute this negative back into here, it's technically a minus 1. So if I ever factor anything out, which it looks like these always will, make sure you include that factored bit right there as well. If this is a negative 1, this is, well, it's a negative symbol. This is a negative symbol. I need another negative symbol there. That's a part that might lose some people, especially if you haven't done completing the square in a while or one of this accord. So I'll be sure to, I think all the other problems kind of use it. So you have to be ready. In some of these problems, you like this one already has a perfect square. You're already taken care of. But this is going to be y equals. So why did I do this right here? Because this is a perfect square trinomial. This is x plus 1 quantity squared. I'm not going to dive into why that is. 8 minus negative 1 is 8 plus 1, which is 9. So here's your vertex form right here. This is where I can graph out of and plot the vertex straight up. Number 8, same-ish, only this time a negative 2 can factor out of here. So we get negative 2 factored out, and we get x squared plus 14x. Here we're going to complete the square, find a value that goes inside here. This minus 108 sticks on the outside, and I will subtract whatever I added here. Keep in mind that it needs to multiply by negative 2 because, hey, this number technically also multiplies by negative 2. It's all about balance. Whatever I add on one side of the equation, I also have to subtract. So 14 divided by 2 is 7. 7 squared is 49. This is a perfect squared trinomial now. And remember, that's negative 2 times 49. Technically, it's negative 98 that got added here. So negative 98 is about to be subtracted when you do negative 2 times 49 here. So this becomes y equals negative 2 times x plus 7 quantity squared. That's the factorization. Negative 108 plus 98 is negative 10. So minus 10 goes there. And your vertex is at negative 7 comma negative 10. And although there are only 4 problems right here that show this, we're not graphing here, by the way. We will be graphing some later, and I hope I have some x equals y squareds as well. This one's as easy as you can get. Don't overthink it. If there's no x term, this is already a perfect square quantity. Subtract this over, subtract that over. Y equals negative x squared minus 9. This is vertex form. It's negative x minus 0 quantity squared minus 9. It is vertex form right there. I should have looked twice at that problem before I generated it. There's nothing else to do. But people will overthink it. They'll take this number divided by 2 and square it. They'll do, it's vertex form. That's all there is to it. Now this one right here, I'm going to try and play this a different route this time. What I'm going to do instead is complete the square now before I move these terms over. It depends on what you're dealing with. This x squared is already a positive 1x squared, and that's a good thing for us. I'll go and subtract it over afterward, and I'll just give you a different look at this thing here. So that x squared minus 12x, let's go ahead and complete the square right there. I have this plus y. I'm going to go ahead and subtract the 30 over. At some point, I need to take that over anyway. And whatever I do on one side of the equation, I can just go ahead and do on the other side of the equation. Compared to that of what I did before, adding and subtracting on the same side of the equation, now I'm going to add on opposite sides of the equation. Just like how did the 30 move over? I just subtracted it from both sides of the equation. Now I'm going to add a number here, which is 36, by the way, and I do it to both sides of the equation. Why is it 36? Because negative 12 divided by 2 is negative 6. Negative 6 squared is 36. You might be wondering why I'm doing that process if you're new to it. It's because this is a perfect square trinomial. Literally, when you factor this quantity, you're asking yourselves what two numbers multiply to make 36 and add to make negative 12. It's negative 6 and negative 6. It's the same number twice, and that's what it factors down into. Now, negative 30 plus 6 is, or 36 is 6. Now I'm going to subtract this whole quantity over. It looks weird to have it written as a whole quantity, but it's going to be y equals negative x minus 6 quantity squared plus 6, like that. And there's our vertex form. Now I could have subtracted the x squared over and added the 12x over, etc. on that other side, but then I would have had to factor the negative 1 then and there. I don't know. I'm giving you a different look at something. Make it easier if you can. Make it easier if you can. And that's how we'd likely do it with circles. All right. I'm going to introduce something new to you now. We got to start talking about focus and directrix here. Quick talk, and I got to do as little as I can, but a quick talk. Parabolas are not just about squaring values. I mean, they are when you compare y to x. But when you just figure out how the points are all related to one another, see, a circle has all your points around a single point called the center. Point, 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 point. They're all equidistant from the center right there. That's what a circle is. Parabola has equidistance from some values as well. If this is your parabola right here, there's actually a point on this, there's a point called the focus, which is right here. I don't know exactly, but it's inside the parabola. And then there's a line outside the parabola called the directrix right here. What these two things do is they are the equidistant portions from any point on your graph, such as the vertex. The vertex is the same distance away from the focus as it is the directrix. This point right here is the same distance away from the focus as it is the directrix. And when I say distance to the directrix, although it's a line, you go perpendicularly to it. This distance here is the same distance, or point here is the same distance from focus as is the directrix. These are congruent. These are congruent. These are congruent right here. And this goes on and on and on. Equidistant, equidistant, like this. It's kind of weird to look at, and my drawing's not perfect to it. But those points are equidistant, and focus and directrix are there. Now the distance from, if I zoom in on that vertex value, if this is your vertex V, and this is your focus F, and this is your directrix D, the distance from focus to vertex is P or C in my other video, and distance from vertex to directrix is also P as well. You would add a P or subtract a P based on whether you open upward or downward. The relationship in P, the way you find P, as it's clearly based off how much your parabola opens and such, and these things change in value. But that distance here, it has to do with A. The relationship is A equals 1 over 4P, or P equals 1 over 4A, depending on how you're trying to find one versus the other. And you're going to see me do that. You're going to see me use P, A to find P, and P to find A. A bunch of different ways. And I don't know which way you want to put it. It all depends on whether you're dealing with you want to deal with a fraction inside here, you can cross multiply, this and that, work a proportion, all your call. But that's what this stuff is, and I'd love to do a proof for you on P equals 1 over 4A, A equals 1 over 4P. But you know what? Time. It's already almost 20 minutes in. Let's go ahead and keep working on it. So, yes, A equals 1 over 4P, or P equals 1 over 4A is that relationship. You can work it one way or the other. It's going to give you the same thing. So let's identify the vertex, focus, directrix, and direction of opening of each graph here. And I can give you a basic version of some of these graphs, but we are going to be graphing these right after in general. So right here, y equals 1/4, x plus and all that. Your vertex is at negative 9, 2, as you know, your HK stuff that's going on. This is a 1/4 here. Now the 1/4 being positive in a y equals x squared scenario means we are opening upward. Opens up, right? This is a graph that does this, right? The focus, when they say identify focus and directrix, they mean the actual point. Where is the focus? Where is the directrix? The focus is an actual point at some xy. The directrix is some equation. It's the equation of a line. So what do we do here? First, we got to determine what P is. When we determine what P is, we will add and subtract P y units up and down from this graph. If this is a graph that indeed opens up, which it is, if it's a graph that opens up, the focus is your y is your, well, literally, it's actually here. It's at h, comma, k plus p. You take whatever your vertex value is and you add p units to it if it opens upward on y. The directrix is literally, this isn't how I think about it. I'm not doing like a formula here, but I kind of am. It's at y equals k minus p. If it's underneath, right? It's a y equals equation. Your k is your vertex. If your vertex is at hk, boom. And then you subtract p from there if it goes downward. Your hk is your vertex. So that's what we're going to do. We're going to find out those values. And sometimes they're fractions and they're kind of tough to deal with. But how do we find it? We've got to first find p. P is 1 over 4a. Your a value is 1/4. 1 over 4 times 1/4 is 1 over 1, which is 1. A p-value of 1 means your focus will be 1 unit up from the vertex as this graph opens up, and your directrix will be at y equals 1 unit down from your vertex. Your focus is at the point -9, comma 2 plus 1, or -9, comma 3. That's the actual location of the focus portion right there. The directrix is going to be at y equals 2 minus 1. You're taking 1 away as it's underneath right there, and which is y equals 1. Directrix is at y equals 1 right there. So that's your focus, your directrix. What do we need? Direction of opening and vertex. Those are the 4 bits. Those are the 4 bits. And I'm going to keep doing that on these as these things change here and there. All right, y equals negative x minus 3 quantity squared minus 9. Still a y equals equation. This one does open downward. I'll write that in a sec. Your vertex is at 3, -9. 3, -9. It opens downward as it's a y equals equation with a negative a value. Your p, I guess we can make it negative. I assume that's what I probably did in the past. Your p is 1 over 4a. 1 over 4 times the a is -1. So it's -1/4. This means we go a quarter down for the focus and a quarter up for the directrix, right? This is a graph that this time goes this way. If your vertex is at 3, -9 right here, we are going to take a fourth away from the y value to get the focus right there. The directrix will be a fourth up from that y value. I hope that that's making sense. So this is where fraction practice has to come into play. And like I said, I'll go faster as we go here. The focus is a single point. It's at 3, comma, and then -9 minus 1/4, right? We're going to be a quarter down from -9. Yes, it's -9 1/4, but I'm going to write the improper fraction version. I don't know if they'll look different from that. -9.25, you have that. I'm going to write it as an improper fraction. That's my way of doing it. Even though graphing it, I think it makes more sense to say -9 1/4 actually, because we will be plotting them. But if I saw an answer key, I assume it's going to say this. 9 times 4 over 4 gives you 36 1/4. So this is -37/4, like that. I don't know if that's a preferred answer for people or not. That's just the way that I grew up with some math stuff there. Directrix is going to be a quarter up from -9. So -35/4. Y equals -35/4 or -8 3/4. -8 3/4 there. And that's the directrix. And again, it's a y equals equation as it's a horizontal line that goes across there. All right. Moving on down. All right. X equals -2 times y plus 1 quantity squared minus 9. This time your vertex is at 9 for h, -1 for k. Vertex is at 9, -1. This is an x equals y squared equation. With it being negative, this actually opens left. Now, how does that change things when it comes to focus and directrix? This graph opens left right here. The focus is inside right here, and the directrix is now going this way. So the focus and directrix means you have to alter x. We're going to go to the left on x and to the right on x, p units to come with directrix. Directrix is going to be an x equals equation. It's a vertical line. It's an x equals equation now. So the p value, p is 1 over 4a, which is -1/8. we need to take the negative 1/8 and we need to subtract it. Well, I do 9 minus 1/8. It's going to go 1/8 to the left over here. This is clearly not drawn to scale, but it's going to go 1/8 to the left over here. So we can do 9 minus 1/8 for the focus. So focus is 9 minus 1/8, comma, negative 1, which is 71/8, comma, negative 1. That's your focus value. That's 8 and 7/8. Your directrix is going to be at x equals, it's an x equals equation. You're going to add an eighth to 9, so basically 9 and an eighth, or 73/8. 9 and an eighth, 9.125, or 73/8, like that. Sorry for the color coding stuff. I'm kind of out of whack with that. Number 14, x equals 3/4 times y minus 6 quantity squared. There's a plus 0 if you're talking about HK. The vertex is at 0, 6. This is an x equals positive y squared version of an equation. This will open right. So that means the focus is going to be to the right of this thing right here. Here's focus. Here's directrix. Now I'm literally going to draw these in some other, in some future problems here in just a moment. P is 1/4a. 1/4 times 3/4. You know what 3/4 of 4 is? 3. So 1/3. We are going to add 1/3 to the x value of 0. Oh, that's easy. We're going to add 1/3 to 0 to get our focus point. And we are going to subtract 1/3 to get our x equals directrix equation. So your focus is actually at 1/3, 6. That's all I need to say. There's not actually much more to that. Add 1/3 to go that way. Subtract 1/3. The directrix is at x equals negative 1/3. Okay, that one was easy enough. Cool. Okay, I kind of want to box some of these up. Take them to go. Okay, awesome. Now we're going to keep doing that, guys. A lot of questions we're going to ask about focus, directrix, etc. Sketch the graph. So get used to it. Let's actually start sketching them as well. I'm going to go ahead and sketch it first. So this is where I'm going to go fast, okay? I start at 4, -6, and it's a stretch factor of 1. So I'm moving. Oh, here I go. -6 plus 9, and I think that's all I can fit. Okay, so here is, oh no. Here is this guy right here. Now this had a positive 1 stretch factor here. So you'll see how I plot the focus and directrix and stuff. And maybe I can also kind of put it to scale for you and see if you can make sense of like, okay, you agree with how that stuff works. So the p value is 1/4a, so that's 1/4. Because this opens upward, the focus is going to be a quarter up from right here. So identify the focus here. It's going to be at 4, what's -6 plus 1/4? It's -23/4. So -5 3/4. -23/4 right here. It's plotted right there. It's a quarter up from -6, right? I'm going to try and let me kind of fix this first here. Sorry about that. Close enough. So it's a quarter up from -6. It's pretty close. The directrix is going to be a quarter down from there. So y equals -25. Whoops. Y equals -25/4, -6 1/4. So y equals -25/4. I'm actually going to kind of draw a dotted line for you here. A quarter down from -6, that looks like halfway down. About right there. And yes, pretty close. That's why I said you're going to start appreciating focus and directrixes that are integer values away. They're spaced apart a little more. All this means is you pick any point on the graph like this one right here. This distance right here and this distance right here are identical. They're supposed to be congruent. Boom, boom. That's all it means. Distance from focus and distance to directrix, perpendicular distance, are equal. And that's what I'm identifying there. All right, number 16. And we're more than halfway done. And you know what? Not even a half hour through, but these are probably the harder problems here as they take longer. All right, my vertex is at, this is a y equals x squared. We're at 1, 1. This is a stretch factor of a quarter. So 1, 1/4, 2, 1, 3, 2 1/4, 4, 4, 5, 6 1/4. All right. Half speed. Okay, I like the wider graph, specifically a quarter, because I know if you saw how it worked before, then you'll know what this p-value is going to be. It's going to look a little nicer. I like the characteristics of it a little better. I think I mentioned that for wide graphs before. Okay, so there's the graph itself. The p-value is 1 over 4a, which is 1. That means, as this opens upward here, we are going to go 1 up. This is the easy part. Focus is at 1 comma 1 plus 1, which is 2. Focus is right here. Directrix is at y equals 0. 1 minus 1, which is 0, which is right here. And there's that. So once again, what this means, I'll just kind of pick another point like way out over here. This point right here means that these two parts are equidistant from each other. This and this are the exact same distance away from that point. If all drawn to scale and all's good and great. They're the exact same distance away from that point. And any other points on the graph there. Cool, isn't it? All right, and that's your focus and directrix on that one. Let's move forward. Hey, negative 1/4. See, I'm glad to see 1/4 whenever we get them, and hopefully you kind of know what they mean. Now, this is an x equals equation, though. So the vertex is at -4, -1. Remember, -4 is the h. So -4, -1 right here. This graph does open left. So 1, 1/4 to the left, 2, 1, 3, 2 1/4, 4, 4, and kind of finishing. 4, remember, is a quarter of 16, if you're wondering where I'm getting those numbers from. That first set of a quarter is not really doing it for me. I'm probably not doing too well in those fraction bits. All right, but it's opening up to the left, and it looks like that right there. Pretty cool. Okay. Focus and directrix. I mean, I'm going to still show you the calculation, but you should know that p is going to be -1. After we do this so many times, maybe I should kind of play that assumption with you with the 1/4. 1 over 4a, which is -1. So this does mean your focus is always inside the parabola, but the focus is at this point right here, and the directrix is at, let me change the colors up. The directrix is at this equation right here. It's one away on both sides of it, and the directrix is a line. So the focus is at the point, what is that, -5, -1. The directrix is at x equals -3. Remember, it's an x equals equation. Boom, like that. And of course, you know what focus and directrix means by now, hopefully. At least you got some understanding of it. All right, 18, we have a 1/2. X equals 1/2, -2, 5 is our vertex. I don't have much I can actually graph right here, unfortunately. I can go, oh, I'm sorry, it goes to the right, huh? So it goes 1, 1/2. What's half of 4? Well, that's 2. Half of 9 is 4.5. Half of 16 is 8. And that's what I can fit there. 1, 2, 3, 4, sure. Oh. Okay. Rightward facing parabola has it's an x equals y squared, x equals positive y squared. Now the 1/2, it's not quite a quarter, but it's also not quite 1. What the heck is the p-value? Right here we're going to get p equals 1 over 4 times 1/2, which is 1 over 2. So a p-value of 1/2 means we're going to be adding 1/2 to find the focus. Focus should basically be right there at that point. And the directrix is going to be this line right here, 1/2 away on that side. So your focus, it's at -1.5, but you know me, improper fraction time. -3/2, comma, what was that, 5? And the -2.5 on this side here, the directrix is going to be at x equals -5/2, right there. -2.5. So how well can you work with fractions and my improper bits? It's your call. If you want to put mixed numbers, you know what? Mixed numbers aren't a bad thing. Decimals could be if you're dividing, by something that's not going to give you an exact decimal. But mixed numbers really aren't a bad thing because for graphing sake, I think I'm just giving what I feel like an answer key would probably give. Now here's the thing. You're going to have to know how to work. I'm going to flip a page for a second. You have to know how to work with improper fractions here. I know these exist right here, so that's the reason why I kind of brought up answer key. They will show up. All right, these ones are in that general form here. Here's where we can benefit from our when should we make the x squared positive versus negative, things like that. I'd prefer putting them on the other side of the equation to force it positive. I think that'll help us. So I'm going to keep this 2y here and move everything else over. 2y equals x squared minus 10x. I'm going to add that 17 over here as well. But here's where I want to complete the square right now. I have a 1x squared. Let's add and subtract on the same side of the equation. It's already a 1x squared. Negative 10 divided by 2 is negative 5. Squared is 25. We add 25 here. We subtract 25 here. Now I do want to get y by itself in a sec, but I'm not going to divide by 2 unless I've kind of already narrowed all this down. So this will say 2y equals, this factors down to x minus 5 quantity squared, and 17 minus 25 is negative 8. Now I get to divide everything by 2 right here, and it's every quantity like this right here. And, you know, it's better to write the over 2 part as like 1/2. That way you can see what your a value is. And, you know, we still have to graph this. 1/2 times x minus 5 quantity squared, and negative 8 minus 2 is negative 4. So I'm going to graph this equation. We still have to do focus and directrix after this too. Okay, so let's do that one. This is a y equals equation. We're at 5, negative 4. Right there, 1/2. We just did one of those. 1, 1/2, 2, 2, 3, 4.5. 3, 4.5 right here. You can fit some more on this side probably. 4, 16, or 4, 8, excuse me. Half of 16. 12.5. That would be about right there. Not quite all the symmetry in the world that I can fit on both sides of this thing, but it's out of my control. 12.5 was half of 25, by the way. All right, that's all I can kind of fit there. Okay, looks asymmetrical, but I promise you it's symmetrical. All right, P is 1 over 4a, which is 1/2. So we're going to go halfway up for focus, halfway down for directrix. Let's make that in green. So your focus here is at 5, excuse me, negative 7/2. It's negative 3.5. Directrix is negative 4.5 or negative 9/2. Y equals negative 9/2. Right there. Boom, boom. Okay, number 20. Now this time, because the x squared, you know, I want to try to keep it as a positive x squared whenever I can. Sometimes I can't really do anything about it. Well, you can do something about negative positive, but if it's already on the right side of the equation, maybe I'll just leave it. But then you have to deal with something like this 3 right here, and we will when we do. Either way, the x squared here is positive right now. Let's go ahead and complete the square in its current form. I am going to move the 28 over because I don't need it on this side. I'm only using the x squared right now. And whatever I add here, I'm going to add right here. Divided by 2 is 4, squared is 16. So add 16 to both sides of the equation. This gets factored and pared down into x plus 4 quantity squared plus 4y equals, that's negative 12. Now I get to subtract this whole thing over. So it's going to be 4y equals negative x plus 4 quantity squared minus 12. And then I get to divide everything by 4, like that. And now we'll get y equals negative 1/4. Ooh, negative 1/4 times x plus 4 quantity squared minus 3. So here's my vertex form of this guy right here. Like I said, whippersnapper fast. Let's do it. Negative 4, negative 3 for your vertex. This does go downward. 1 1/4, 2 1, 3 2 1/4, 4 4. And reflect. Okay, there's my downward facing graph. If you know your 1/4 by now, 1 over 4 times negative 1/4 is negative 1. So your p-value will be negative 1. I'm going to save some time there. That means your focus is 1 down from there. Your directrix is 1 up from there as a horizontal line like that. So these ones are pretty easy to mention what they are. Your focus is at negative 4, negative 4. And your directrix is at y equals negative 2. Okay. All right, a couple more from the general form here. This time the y squared is, well, that's the one that's being squared. So I'm going to get x by itself. And, you know, I'd very much like to, it's a positive y squared still. I'd very much like to put the y squared next to the 4y. And then complete the square there. My negative 8, I'm going to go ahead and add over. And I'm going to add something to the other side with it. Well, this is a 1y squared. That's good. 4 divided by 2 is 2. Squared is 4. Add 4, add 4. So this becomes 3x plus y plus 2 quantity squared equals 12. I get to subtract my y plus 2 quantity squared. And I get to divide everything by 3. That'll be x is negative 1/3. I don't think we've seen one of those for focus and directrix. Y plus 2 quantity squared plus 4. Now it's also an x equals equation. As it's negative, we'll be opening left. So the vertex is at 4, negative 2. We got a 4, negative 2 vertex right here. 1/3. 1/3. I think we graphed at 2/3, huh? 2 4/3. I was about to say 2/3. 2 4/3. 3 3/3, which is 3. Excuse me, 9/3. 9/3, which is 3. 4 16/3, which is 5 1/3. 3 4 5 1/3. 5 25/3. You know, I don't really like these numbers. 5 25/3, which is 8 1/3. 6 7 8 1/3. 36/3 is 12, and that's actually right there. So not my favorite points outside of the 3 and the 36 and such, but I like to make my curves smooth. I like to fit what I can. Makes for a nice looking thing, and very accurate when it comes to focus and directrix talk, if we ever wanted to actually bring up that part of the conversation and say, well, see, here's where it ends up. Problem is, I do believe that the focus and I believe the p-value is also going to be a fraction, so that's no fun. This curve's a little uncalibrated, but I think if I just move it up a little bit, not bad. Actually, it's pretty good. All right, so the p-value. P is 1 over 4a, which is 1 over negative 4/3, which is negative 3/4. So we'll be going 3/4 left for the focus, basically right there, and 3/4 right for the directrix, which is basically, just basically there. So basically, 3 1/4, comma negative 2, and y equals 4 2/3, or 4 3/4, I should say. But you know me, or x equals 4 3/4. But you know me, improper fractions, ahoy me hoy. 3/4 from 16/4 is 13/4, so 13/4, comma negative 2, and then that's 4 1/4 or 3 1/4, and then what was that? Directrix. Directrix is x equals 19/4. Add 3/4 to 16/4. All right, focus, directrix. Last one in conic form here. Yeah, these slowed me down a little bit. I'm at the 42-minute mark, and I barely added problems. This one here is the x squared again, but because it's negative, I'm going to go ahead and add it over. I still have to factor out that 3 before I do completing the square, though. So this will be 4y. I'm also going to add the 71 over. 4y equals 3x squared plus 30x plus 71. Okay, I'm going to factor that 3 out of those two terms right there. 4y equals 3 times x squared plus 10x plus blank, and then plus 71 minus blank. Now this blank here is also going to be multiplied by 3, just like this one is right here. That's that fly in the ointment bit. 10 divided by 2 is 5. 5 squared is 25. And we're going to multiply the 3 by 25 there as well. Only this one stays on the outside, as we are going to be factoring 3 times x plus 5 quantity squared. 71 minus 75 is negative 4. And then we divide everything by that 4 with y. We get y equals 3/4 times x plus 5 quantity squared minus, divided by 4, right? Minus 1. So it's a y equals x squared again. It is a positive one. Positive opening, positive x squared. Negative 5, negative 1 is your vertex. We are going to go 3/4. 1 3/4 of 1. What's 3/4 of 4? 3. So 2, 3. What's 3/4 of 9? 27/4. Set 6 3/4. 6 4, 5, 6 and 3/4. I think that's all I can fit. I wanted the 4. 3/4 of 4 is 40 is 12. And I can't, that's too high up. It's probably somewhere up there, but I can't really fit that one. This graph could have been a little nicer if I could have fit that 12. I really would have liked that one. Okay, so that's what I can fit there. You can see we're skirting by a table, guys. Really makes this a nice, fast venture when you know what you're doing with your fractions. Number sense is really good for these. Good for the soul. I still need to focus in directrix, though. The p-value, p is 1 over 4a. So that's 1/3. So we'll be going 1/3 up from here, not very far, right there, and 1/3 down from there. Yeah, that looks like 1/2. Maybe a little tick. Yeah, 1/3 down from there. So this is a focus of negative 2/3. So -5, comma negative 2/3, and then negative 4/3 for the directrix. Y equals negative 4/3 as we go 1/3 down from -1. And there are your values. Okay, so there are the points right there, and we are settled. Let's go ahead and move forward to this last page, if you will. We are going to sketch the graph of each parabola here. They don't ask for anything else, but that means I basically need to find the a value. I need to find the vertex in all these, and the a value in all of these is pretty much the idea. And you know, I'll be good from there. So they're not asking plot these points. However, these points might assist you in what you're going to do. For example, the vertex is at -5, 8. It's all the whoa. I hope it goes downward. And the focus is at -5, 95/12. Now 8. You got to figure out how far 8 is away from 95/12. That'll help you determine p. Okay, so you know p's the distance from there. Now, as you can tell, it's a change in y. The x stayed the same. That means this 95/12 is either up from the vertex or down from the vertex. I'm gonna venture to guess it's down. I actually know it's down because 8 is 96/12. And you know what 95/12 minus 96/12 is? That's -1/12. This is going to be -1/12. And I don't care where the focus is, just that it's underneath. That helps me know and understand this graph opens downward. That's where the focus is, so it opens downward. My goal is to use this. This is p. P is -1/12. And I don't know if you would know whether it's positive or negative other than understanding that if the focus is always inside the parabola and it's underneath the parabola, then I guess your a would become negative anyway. But your p, you should do focus minus directrix value, and that's your distance. Focus minus vertex value. So your p is -1/12. Well, what's your a? A is 1 over 4p. 4 times -1/12, which is 1 over -1/3, which is -3. So your equation is y. It doesn't matter what the equation is. It matters that -3 is your stretch factor now. But the equation is y equals -3. I wish I had to write the equation. I probably will. Times x minus h quantity squared plus k. So we already have the vertex plotted right there. Stretch factor of -3 means 1, 3, 2, 12. And really that's all I can fit here. And that is the graph based on that. I think getting the equation is kind of important from that there. So what we're going to do in that problem, and the next problem here, is determine p and use that p to generate a. That's given that we already have what the vertex is. Okay, the next problem here, the vertex is at 4, 8. Looks like it's all the way at the top again. And then your focus is at 13/2, 8. So the height didn't change this time. 13/2, hey, yo, if you don't, we can use this one together if you want. That's 6.5. That's 6.5, right? 6.5, 8. So your focus being over here means this graph opens up like this. If that's your vertex, and I don't know how to sketch that part of the graph going upward, it's not going to be the best, but your focus is all the way over here. That also probably means it's really wide like that. That means your a value as it's opening up in an x equals, oh, by the way, this is x equals y squared. Remember that. This is x equals y squared fashion because of the focus being to the right. Make sure you do that when you draw the graph there. And we got to find the p-value, right? So the p is the distance between 13/2 and, well, 8/2. P is 13/2 minus 8/2, which is 5/2, right? 2.5 away as this opens this way. The a value is 1 over 4 P, 1 over 4 times 5 halves, which is 1 over 10, which is 1/10. Yeah, that a value of 1/10, guys, that is compression right there. The equation, and I know they didn't ask you to write it, but the equation is x equals 1/10 times y minus 8 quantity squared plus 4. Your vertex is at 4, 8 right there, and it opens up. Now, plotting this is not going to be easy for me going upward, and the 1/10 doesn't help very much either. We go 1 1/10, 2 4/10, which is 2/5. That's not much. 3 9/10, which is basically almost 1. 4 16/10, which is like 1.6. 5 25/10, which is 2.5. That meets the focus. 6 36/10, which is 3.6. You're just dividing them by 10. It's not very much I can do on this graph to kind of help. I'm not even going to plot points on that side. I'm going to be there's not much I can do there, guys. It's a fun graph. It's kind of cool. The focus is equidistant. By the way, they haven't asked for directrix, which would have been 2.5 away on this side. But, any point, focus, directrix, equidistance right there. But they're just asking to sketch the graph, and that's really the best I can do. All right, this time you're going to be given the vertex and the directrix. So the directrix is underneath the vertex, it's outside of the parabola. It's whichever way it faces. So notice it's an equation this time, y equals. Our vertex is at negative, this isn't even on the graph. Sorry. The vertex is at negative 9, negative 9, 3. Someone hit a home run back there? I think I just saw a home run on the video, or at least a replay. Negative 9, 3. This isn't even on the graph. I apologize for that. Directrix is, maybe we could change it. Directrix is y equals 13/4. Now, y equals, I'll tell you straight up, a y equals equation is a horizontal line. That means that if it's above, your graph faces downward. If it's below, your graph faces upward. But this is a y equals x squared equation for sure. Is it positive or negative? It depends on the distance between 13/4 and 3, which is 12/4. What's the distance between those ones? You want to do 12/4 minus 13/4. I'm sorry, you want to do 13/4 minus 1. I'm trying to think. You want the P, the directrix, 12/4 minus 13/4 is fine, I think. That's what I want to say, which is negative 1/4. So your P is negative 1/4. That means you go a quarter up or down, whatever, to find. So the directrix is it's above it because it's higher than 12/4, right? The focus would have been a fourth down from it. Anyway, 13/4 is above 12/4. The idea here is A is 1 over 4 P, which is 1 over negative 1, which is negative 1. Your stretch factor is negative 1. That means this is a y equals negative x minus h quantity squared plus k. So not much I can go this way. That's fine. 1, 1, 2, 4, 3, 9. Here, I'll wing it. 1, 1, 2, 4, 3, 9. That's what you get when you give me that graph. No. Okay. Sorry. All right, 3 more problems. Can I beat the clock? I got 7 minutes. Vertex, directrix right here. This is an x equals equation for directrix. That means it's a vertical line. That means it's some sort of x equals y squared equation. Now, negative 10 compared to this, that's negative 80/8. That's to the left of negative 79/8, and this is directrix, right? So negative 10, that doesn't even fit. Not only does that not fit, this graph goes left. I don't know what to say about these. I don't. You know what? I believe, now I do know what to say about these. Now I know. I placed the graphs in here. They asked you to come up with, I think they asked you to come up with the equation, and I changed it, and I said sketch the graph. So I apologize that some of these will, that's me. I apologize that some of these will not be on the graph. 9, 10, and 9. Oh my goodness. Let's come up with the equation and just rough it out. We're not even going to be able to work stretch factor stuff the way that we want to. But let's come up with the equation. So the directrix is negative 79/8. This is negative 10/8 right there. P is negative 88. Negative 88 minus negative 79/8. What's the difference between those? Well, it's negative 1/8. So this graph is going to go left right here, right? Because the vertex is to the left of the directrix. Directrix is basically right here. The a value, a is 1 over 4p, which is 1 over negative 1/2, which is negative 2. So the equation as it's a y equals x squared equation, or excuse me, x equals y squared equation, is x is negative 2 times y, what was it? 9? Y minus 9, quantity squared, minus 10. There's the equation. Now, being a negative 2 stretch factor does open left, and it goes a little, it's a horizontal stretch factor, so it goes a little sharp. 1, 2, 2, 8, etc. That's on me. Complete. I was wondering why this one was perfect. I was wondering with these other ones what was going on. Now I'm realizing, my bad. And this doesn't seem to stop. This doesn't seem to stop. All right, now this one is focus and directrix. That means your vertex is in the middle of these. Sometimes it's easier to plot these points out or average your values. There are a lot of different ways you could talk about what you're going to do here. Basically, let's put it this way. Say that your parabola did this, and your focus was here and your directrix was here. I mean, you wouldn't know the parabola yet, but what you have to understand is the parabola's vertex is the same distance away from these here. These are both a distance of p away from here. That means the total distance between these is 2p. So if you want to find out what p is, take half the distance of what's, between those two, right? I mean, there are kind of a lot of ways to talk about it. You can also average the values out because all you have to find is the actual vertex itself. What's the average of negative 1/36 and 1/36? I can tell you it's 0. So yeah, I don't know what's the best way to kind of go about this thing. Sometimes these aren't good fractions, bad fractions, what have you. I'm questioning how sane my students will be after seeing questions like this. I'm sure I'm going to give them much easier ones beyond this. Anyway, you can tell that the it's a y equals equation for directions. Look, 136 is just hugging 0, really, and negative 136 is on this side. Oh, it's at negative 8, negative 136 down there. This is not your vertex, by the way. This is your focus. That means the vertex is, this is probably sharp. That means the vertex is on there. So yeah, your vertex is, listen, the x value is negative 8. That's not going to change. The y value is going to change, and it's the average of these two values, or it's half the distance between these two values. The distance between these two values is 1/18. Half that distance is 1/36. Look, it's 0. If you understand where these points are, negative and positive, same distance away from each other, it's 0. Now it does open downward. It does open downward because the focus is underneath right here. The p is negative 1/36 because the distance from 0 to negative 1/36. And then the a value is 1 over 4 times negative 1/36, which is 1 over negative 1/9, which is negative 9. I don't even know what to say for this graph. It's 1, negative 9 down. This is very sharp. It's 1, negative 9, 1, negative 9. It's as sharp a parabola as we've ever done before. And of course, it's right near the edge of the graph. All right, one more. Let's beat the clock. 2.5 minutes left here. See, you can probably eyeball how this focus directrix thing works. They're both over 4. So what's between negative 19 and negative 21? That's where your vertex is. It's at negative 20 on x. Vertex is at negative 20 fourths, and I'm going to change that, comma negative 8. That y value shouldn't change if the x value was the one that changed because focus and direct, it's a sideways parabola. Now, what's negative 20 fourths? That's negative 5. So negative 5, negative 8. By the way, I didn't write an equation for this one. This would have been y equals negative 9 times, did I write it for the other ones? Negative 9 times x plus 8, quantity squared, and then plus 0, but there it is. All right, this one right here, the p value is the distance from vertex, negative 20 fourths, to focus, negative 19 fourths. Now, negative 19 fourths means it's going closer to 0. That means that's 1/4. It's going toward positive, so it's a p. It's going to open to the right. The a value is 1 over 4p, which is 1. So the a value is 1. So this is going to be an x equals 1 times y plus 8 quantity squared, and then your plus h, I should say, is minus 5 right there. So again, your vertex is at negative 5, negative 8 right here. And your stretch factor is 1. So it's a 1, 1, 2, 4, 3-9 business right here. And although I can't really fit it, although I do apologize for the graph bits, I think the idea is to write the equations. And there you go. I'm trying to beat the clock, sorry. Okay, that was a lot of stuff right there. And listen, some of these will get hard when it comes to fraction stuff. Some of them will be a little bit easier, but that's the kind of stuff that's going on. All right, guys, that ought to do it for this one. It does look like I did beat my hour. I could stall at least till that hour button thing hits. This is Mr. Robinson. Now, when I do a review, I am going to try a lot harder to make sure that I get kind of more accessible problems of this Accord. Sometimes they're very hard, but sometimes the access can be a little bit easier depending on what's asked for you. All right, that'll be it for this one. Check the links down below for more video stuff. Take care. I will see you in the next one. Hopefully a little cheerier from now.